Right. So are any of you guys here also doing physics? Yeah or no? Anybody here doing physics as well?
Um,
As a physics course.
Yeah.
Anyway.
Desron do physics. Desron, it was like 3 months he do physics with man. It's like 3 months.
Yeah.
Desron do physics in 3 months. He never even touched a lab before. And he got a 2 in physics in 3 months. Big up Desron. Big up Desron. Right? Right. So what is a vector? So a vector is something that has both size and direction. So meaning that it could be positive or negative. Somebody's writing a little note about that. Vector is a quantity both size Let me give you an example, right? Sky. You ever do physics before?
no, sir.
No. I don't think you need to do physics to understand this. And you know what a force is? Yeah or no?
So, can you elaborate?
Say that again.
So, can you elaborate?
Okay. If I push you, aren't I pushing you with a force?
Yes, sir.
And I could push you in different directions.
Yes, sir.
Right. So you know what a force is then. So an example of a vector would be a force. That's what a vector is, right? So let me give you an example on me. If I have this block over here, and I could push the block in this direction, or I could push the block in this direction. Yeah or no?
Yes, sir.
So if so I'm just saying, right? I'm just saying, if I push any block in this direction, then I could call that positive. So let me just say I'm pushing it in this direction. So I would say the force here is 5 newtons. However, if I take the box now and I push it in the opposite direction, do you think it'll be positive 5 or negative 5 newtons? What do you
Negative.
Negative 5, like I tell you, like I said, you don't need to know physics to understand this. Like, all right. Carissa, let me know if you're following so far. So I'm saying a vector is just basically something that has both a value and a direction. So the direction would be signified by whether it's positive or negative. Tell me if you understand that. Carissa? Again.
Yeah, I understand them.
All right. Nice. Okay, Simran, do you understand that I could push this box either to the right or I could push it to the left? Yeah or no?
Yeah.
Yeah.
Somebody asked a question in the chat.
What somebody said. Don't worry too much about the notes because at the end of class, I'm going to send the notes. The main thing is that you understand everything that's being taught here. That's the main thing. Right? You understand the concept. All right. Who to ask? Adetola, do you understand that I could push this block with a force to the right, and I could also push it with a force to the left if I wanted?
Yeah.
So if I'm pushing it to the right, I would say it's a positive force of 5 newtons. If I'm pushing it in the other direction, then I could say negative 5 newtons to 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 symbolically say, I'm pushing it to the left. When you see negative, that means you're pushing it in another direction. Does that make sense?
Yeah.
You're sure?
Yeah.
Great. So let's look at the Cartesian plane now. If I really want to copy on the notes, I will try to facilitate that. Does any of you, does anybody here know what the Cartesian plane is? The Cartesian plane. It's just a fancy word for the X and Y axis. Until you know about the X and Y axis.
Yes, sir.
Yeah, so the Cartesian plane is just that, right? So, question, guys. All the values here, would the values there be positive or negative? So this is 0 here. Would the values here be positive or negative? Somebody tell me.
Positive.
Positive, right? If you're going in this direction, it's going to be positive, right? Great. Adetola, if I'm going upwards, do you think that's positive or negative?
If we're going upwards, positive,
Okay. If I'm going to the left, positive or negative?
negative,
If I'm going down, positive or negative?
negative,
Right. So Adetola, and we could all agree that on this Cartesian plane, the X and Y axis, and I could move left and right, up or down. Do you know? I could do that?
yeah,
Right. Just keep that in mind. Keep that in mind, right? So, Carissa, is there anything you didn't understand so far? Okay, and Carissa, what about the rest of you all? Do you all understand what I'm saying is understood to be positive direction and negative direction?
Yes, sir.
Okay, great.
Yes, sir.
And just to summarize, if I'm going to the left, would it be positive or negative? If I'm going to the left, positive or negative?
Negative.
Right? Negative. If I'm going to the right, positive or negative?
Positive.
Mhm. If I'm going up, positive or negative?
Positive.
Positive. And if I am going down, positive or negative?
Negative.
Great. Right? Yeah. Great. So if you all want, you can copy this down. Let me hear what most of you all want to say. So would most of you all prefer if I moved on, or would you prefer if I gave you all like 5 minutes to copy down what's here? What do you all think? What would you all prefer? Time to copy down or move on?
Yeah, I would prefer the notes because I didn't have time to write down the other notes from the classes I missed, so I would just use what you sent.
Okay. What about the rest of you guys? By the way, Kadisha, you're not missing anything. This is like a fresh start of a new topic. So you're fine. Trust me, you're fine. Yeah.
Yeah, but I watched the other videos, even though I couldn't copy down everything, so the notes is coming handy. Thanks.
Okay, big up you. Right? You really watch all the videos?
Yeah, watch all the videos. I missed like 2 classes because I was
I
had
know, I know it
other
was
stuff
real
doing.
sick.
Yeah,
It's sounding good now. It's sounding good. Right? So
yeah.
I'm gonna give it 3 minutes, right? Don't think that's enough time, but take 3 minutes and see if you can copy down in that time. 3 minutes. So essentially, when you have vector, I just want you to think about directions. There are different types of vectors, right? Column is the one we'll be focusing on, and there's another kind. Okay, so that's it. So let's move on, right? Right. So I want you all to think of vectors as directions. What do I mean by that? So who to call? I need somebody to call upon. Sky. So remember when I told you you could either move left, right, up or down on the Cartesian plane? Remember I said that?
Yes, sir.
Okay, great. So I want you to think of another example as well, right? Check this example out. Let's just say I wanted to go from Pinal to Port of Spain. Now, unless I take an RTTRS or something, could I go straight from Pinal to Port of Spain? Or do I have to go Sando first?
Yes, sir.
I had to go Sando first, right? So let me show you one of the most basic concepts of vectors. Check this, right? All right, check this out. All right, so let's just say that this is Pinal over here. That's Pinal, right? This is San Fernando, right? And this is Port of Spain. So if I want to go from Pinal to Port of Spain, could you all tell me how I would make that trip? Could somebody tell me? I want to go from Pinal to Port of Spain. So that's why I drew the arrow over here. How would I do that? Somebody tell me. How would I have to move? Kadisha, how would I have to move if I wanted to go from Pinal to Port of Spain? According to this diagram. How do you think?
So you can repeat the question.
Okay, so if I wanted to go from Pinal to Port of Spain, how would I be able to make that trip according to the diagram?
You go from top to from bottom to top, or you go across, you go up and then come. No, you say Pinal. So, well, from bottom to top.
Wait, tell me it like in sections, right? So Pinal to where to where?
From Pinal to, well, you could go from Pinal to Sando and Sando to Port of Spain.
Right, that makes sense, right?
Yeah.
So for me to go from Pinal to Port of Spain, I had to take a horizontal movement. This is a very oversimplification, but you could see here, if I want to go from Pinal to Port of Spain, and I have to make a horizontal movement. It's a horizontal movement.
Right.
And then I made a what kind of movement? So this is horizontal.
Mm-hmm.
And then I made a what kind of movement? What would I call that?
Vertical.
Right. Great. So this is the simplest concept of a vector. So I want you all to think of vectors as directions. So the most basic form of a vector is referred to as a column vector form, right? Column vector form. Let me show you what the column vector form looks like. So let me just say you had a vector v, right? You would write it as x comma y. Well, not x comma y. You write it as x here, y here, right? And if you look at the Cartesian plane, the x-axis is what directions? Tell me, Kadisha, if you're on the x-axis, how could you move? If you're moving along the x-axis, what directions could you move in? So this is the x-axis. If you're on the x-axis, you can either move what two directions?
You could move. So we went right, then we went up.
Oh, wait, I
So you
thought
could go from.
wait, forget about what I just want to show you, right? I want you to just focus on the x-axis. If you're along the x-axis, how could you move? What's the directions you could move in?
From left to right.
From
Well,
left to right.
negative to positive.
Right, left to right. Great. So that would mean that x would correspond to the horizontal movement, right?
Right.
Right? And what do you think y would correspond to?
The vertical.
Yep. Nice. So that's one way you could write a vector. Another way you could write a vector is in a unit vector form, right? Unit vector form. Right? And in this form, it would look like xi plus yj. So it's the same concept here, right, Kadisha? So we understand that x would be the what kind of movement?
X will be horizontal.
Right? X is horizontal.
All right, so there's another way to write it.
Yes. You would see this sometimes.
Okay.
Right? And all I means I would correspond to the x-axis and j would correspond to, let me say it in the proper way, right? I would correspond to 1 unit on the x-axis and j would correspond to 1 unit on the y-axis. So if I said 5i, that means I'm going to move 5 units along the x-axis. And if I said 7j, that means I'm going to move 7 units on the y-axis. Understand? Yeah or no? How you feeling about that? Okay, they're hearing you. Right. So something to keep in mind. The convention is that you move horizontally first. So move nice. So I don't know if you all want some time to copy this down. I need somebody to give me constant feedback. I don't like this quiet thing. Right? Adezola, you there?
Yes, sir.
Okay. I need a good bit of it to constantly talk because I will lose my mind if I just hear in quietness. I don't low on energy.
So
Yeah. Selma,
I have been too thin and things, so I try not to talk how much now.
you have tooth pain? Like toothache?
Yeah. Yeah, I don't know what's going on, but it's been so long and things.
Okay, I ease up. Selma, I'll call somebody else then. Right? Ria, you there?
Yes, sir.
So Ria, you understand in general just how I was saying so far about a vector?
Yeah, more or less.
Okay, great. So you understand if I wanted to go from Penal to Port of Spain, I could go from Penal to Sando and Sando to Port of Spain.
Yeah.
That make perfect sense, right? And that makes sense?
Yeah.
Great. So I'm going to move on now. So these are the two forms you would typically see, the column vector form and the unit vector form. But when you're working with vectors, move horizontally first, right? Move horizontally first. The next main thing you should know is a position vector. Right? That's the next important thing you should know what is. So a position vector, what is that? This is basically just a vector that starts from the origin. So this is a vector that starts from so let me show you guys what I mean by that. So you know what? I will just draw my own. 1 eternity later. So what do I mean? The vector starts from the origin. What do I mean by that? So, do we even know what the origin is? Well, the origin refers to 0, 0. So this is the origin over here. That's the origin. So, Ria, I'm going to put down a point. So let's just say I had this point over here. And I call this point E. So let me call this point E. Right. So in this case, right, Ria, I went from the origin to point E. Yes or no?
Sorry, I was muted. Yeah.
So you can see that, right? I started from the origin and I went to point E. Make perfect sense, right?
Yeah.
Nice. How did I do that? So remember, a vector consists of a horizontal movement first, then a vertical movement. So if we are starting from the origin, how should I move next if I eventually want to reach here? Tell me the horizontal movement I would have to make first. So I'm starting at the origin, right? What next? So tell me how I should move horizontally. See if you can figure this out.
You go to the right.
Better go to the right. How much space is to the right?
5 or
Nah, not 5.
4.5.
Nah, 4. Check it out.
Oh, okay. Okay.
Right? Then you would have to move how much space is up?
3.
3. So that vector would be, that's just simply 4, 3. So easy it is.
Ah,
That's so easy, right?
yeah.
Yeah, there's really no tricks to it. Let me use this. This a lot neater than the one I draw. You shouldn't be confused with this one. All right, so Ria, let's just run through this back again, right? So let's suppose that you're starting from the origin, right? Right, so you're starting from the origin over here. And I have this point here, E. My question to you is, how would I go from O to E? That's my question, O to E. Well, if I want to go from O to E, I would first have to move in what direction?
Horizontal.
Right, I would have to move horizontally. So I would move 4 spaces to the,
Right.
and then,
3 spaces up.
right. What? Why the color change? This new update is horrible. Jeez. What? GoodNotes was never this stupid, eh? Like, I don't know what happened. Like, ever since this new update, like, GoodNotes is like the epitome of idiocracy. Like, it's so bad. Precious, you don't find the new GoodNotes like horrible?
Not really. It working fine for me though.
That's good to hear. Like, I find it very frustrating. Okay, cool. Right. Like, it's slowing me down a lot. All right. So, Kadisha, can you see that if you want to go from O to A, you would have to move 2 spaces to the what? What's the two? Four
To the
spaces.
right.
4 spaces to the right. 4 to the right. And then what next?
Um, 2 spaces up.
Nah, that's not 2 spaces.
Well, a 1.5.
Nah, that's 3 spaces. Check it out.
All right. Okay. Yeah.
Right? So if I would have to move 4 spaces to the right and then 3 up. So in other words, vector O to A. So I would write it like this. So vector O to A. Notice the little arrow on top showing the direction. So O to A would be equal to, I have to put my horizontal movement first. So my horizontal movement was 4 and my vertical movement was 3. We understand that?
Yes, sir.
Great. I'm going to put on another point. What if we had a point over here? I want you guys to figure out what the vector from the origin to this point would be. And I'm going to call this point B. So how would I move from O to B? See if you guys could figure that out.
So -5, -6.
Say that again?
-5, -6.
Correct. -5, -6. All right, so you would have to move 5 spaces to the left. And then you would have to move how much spaces down? Tell them, Sky. You'd have to move how much spaces down? 6 down, right?
Yes, yes, yes.
Right, Kadisha, let me know if you understand everything here. So we are going 5 to the left, and then 6 down. Right? So that vector O to B, that would be equal to my horizontal movement on top. So that would be -5. And my vertical movement, which would be -6. Does everybody understand that?
Yes, sir.
Nice. Another way to write O to A, I could also write it as 4i plus 3j. That's an alternative way I could write it as a unit vector form. And I could write O to B as -5i minus 6j if I wanted.
So if the line in the point in between the two numbers on the vector, how much that will be?
So
It will be a half.
you're wondering like if it's over here?
Yeah.
Yeah, it would be a half. It'd be a half,
Okay.
right? So it would just be a half of this. So like if you wanted to find the midpoint of O to A, you could call that O to C. O to C would just be equal to a half of O to A. Right? So a half of O to
Okay.
A, that would be a half by 4i, right? Plus a half by 3j. So that'll be 2i plus 3 over 2j. I mean, if you understand that. So you just find a half
No.
of A.
So I get lost.
You get lost? Okay.
Yeah, somewhere.
Let me go even simpler, right? I'll use this format. So if we had a point that was in the middle of O to A, I could call that point C, right? You okay with that?
Yeah.
And we could both agree that O to A and O to C, they are in the same direction. Yeah? And they're in the same direction?
Yeah.
Right. The fancy name for that is collinear, right? They're collinear. They're on the same line and the same direction. Now, since that's the case, O to C wait, just address that confusion there. You understand that this vector will be O to C, yeah or no?
Mhm.
Because it's starting
Yeah,
from the origin. So O to C would just be a half of what vector?
4 and 3.
O to A, right?
Oh, yeah, or the A, sorry.
That's not a problem. When you're doing these vector questions, you write the notation first like this, then you
Mhm.
substitute. All right? So
Okay,
you can see here that O to C is just a half of O to A. Nice.
right.
So O to A was 4, 3. Understand?
Yes.
So you're gonna find a half of 4. So a half of 4, 2. And
Mm-hmm.
you're gonna find a half of 3, which is just 3 over 2. And that's the answer.
Okay, right.
You
Yeah, I
understand?
understand. Yeah.
Nice.
So you could use this format instead of the one that you just did.
Yeah, sure. It depends on the question.
Because
Eh?
the
Depends on
one
the
you
question.
just did, that that look confusing.
When we do more questions, you can see that it is only look confusing, right? But don't worry, it's not. All right. So let's just do a quick recap. A vector is something that has size and direction. So positive or negative. We understand that left is negative, right is positive, up is positive, down is negative. Cool. In a vector, you put in the horizontal movement first, then the vertical movement. Horizontal first. A position vector is a vector that starts from the origin, right? So are we okay with everything that was talked about so far? We good?
I have a
Yeah.
question, right?
Sure.
The arrows on top, like on top of OA and OB, what that signifying?
Check this, right? Over here, you're going from where to where?
Right? You're going up.
Nah. Check it.
So the
You
O
start
to
from
A.
O to A, right? You're going
Right.
from O to A.
Yeah.
Check this out. See?
Right.
O to A.
So if you're going from A to O, the
If
arrow go the next direction.
I hear what you're saying, right? But that's not the
Mhm.
standard way you write it. You would write A to O like that.
Also, no matter what, the arrow would always be facing that direction.
Yeah.
Okay. All right.
And that brings me to another point, right? So, Carissa,
Mm-hmm.
if O to A is 4, 3, and we could both
Mm-hmm.
agree that negative OA would just be in the opposite direction,
Yeah.
right? So, negative OA would actually be negative 4, negative 3.
I thought like if it would have been negative, the arrow would have been facing the other direction.
I understand why you say that, eh?
As it on the other side
And
of
it's
the
logical
screen.
to say that. But this is just the convention.
Okay.
Yeah. So if you add a negative sign, that means you're gonna flip the direction. I think you can understand what I mean, because if I were to put a
Yeah.
negative by the 4, if I put a negative by that 4, now that will mean 4 like that, switching the direction.
Mm-hmm.
So these are some things you need to keep in mind. So let me do a question now. Let me get my old notes. Okay, great. So I want you all to try this question. So they are asking us to write O to R as a column vector. O to R as a column vector. So I'm giving you all 1 minute for this one. This should be easy. Okay, go. Write OR as a column vector. Just to remind you guys, a column vector looks like this. So you put the horizontal first, then the vertical. Right? This is our column vector. Right? This is our column vector. So the column vector form will be horizontal, then vertical. Let's run. Let me know if you're there. Let's run again. I know you say you're sick, right? So I can ask if you go. Right, but if you understand everything, you will let me know. All right, did any of you guys get an answer? OR. Simran, did you get an answer for O to R?
Would it be -1 to 4?
Yeah, be -1. Right? Carissa, let me know if you're confused by that, if you got -1, 4.
I got it.
Nice. So if I want to go from O to R, I would have to move one space to the left first, and then I would have to move 4 spaces up. Kadisha, let me know if you understood that. So,
Yes, sir.
right, 1 to the left, and 4 up. So O to R is just simply, right, -1, 4. All right. For those that did not figure it out, I want you all to try O to Q. See if you could figure out what O to Q is. Try to find O to Q. As soon as you get an answer, call it out. Don't stick. So how would I go from O to Q?
You go across 5 spaces.
I spaces to what?
Yeah,
Right? So
and then go up 2.
right. So my answer gonna be 5, 2, right?
Yeah.
Nice. So this thing will be easy.
I know the complicated part, right? You given easy sum.
No, trust me.
Don't give easy questions like that.
This is a CSAT question. This is a CSAT question. This is a CSAT question.
I don't believe that. Them things become so simple.
No, this is a CSAT question. This is literally a CSAT question, right? Right.
The other part side.
Yeah, we could do the other parts just now. Don't worry. Right. So O to Q is 5, 2. So now I have a question. Could any of you all figure out what Q to R would be? So what battle is. How would we go from Q to R? How would you go from Q to R?
So consider any point that you have to go horizontal first, right?
Yeah.
You go to the left.
How much units to the left?
You go across
9 spaces. -9 spaces to the left.
Nah, not -9. So guys, check this out, right? So what we want to do is we want to go from Q to R. So we're starting at Q, and ideally we want to go to R. So this is that's what we're doing. So how would I go from Q to R? Horizontal movement first, then vertical movement. So Anna,
7 spaces to the left.
7 spaces to the left. You're close, but not quite, not 7.
6 spaces to the left.
Yeah, 6 spaces to the left is the correct answer, right? If you're an unbeliever, check it out, right? Check it out. So that's 1, 2, 3, 4. Right, so 1, 2, 3, 4, 5, 6.
My bad. I didn't see you was going 2 centimeters.
Oh, yeah, there's trick people like that. Gotta be careful, right? And this one would be 2, right? So we're going to see 6 spaces to the left, right? And then 2 up. So QR would just simply be 6, 2. Are we okay with that? Is everybody okay with that?
Yes, sir.
Great. Now that brings me on to the triangular law of vectors. That's something we need to look at.
So I have a question, right?
Sure.
Even though it end up on the
Wait, I make a mistake. Before I tell
negative side.
-6. Be -6.
Right. Okay, well, all right, cool. My question not valid no more.
Yeah, sorry about that. Right? Because it's 6 to the left and then 2 up. Right? Cool. Let's look at the triangular rule of vectors now. Triangular rule. Great. So, Carissa, as you would have seen with the example with Pinal and Port of Spain, it's not always a case where you could go straight to your location. Sometimes you'd have to break up your destination into small parts, right? You'd have to break it up into micro destinations if you want to reach your final destination. So that's what the triangular rule of vectors says. It says that if you want to reach from one place to another place, you have to break up your journey into parts. So check this out. If I want to go from O to A, so this is O, and I could call this B if I want. All right. So, Carissa, if I want to go from O to A, how could I go from O to A?
Yeah,
If you
that'll
look-
go for to B and then B to A.
Yes. Nice. Does everybody understand that? You guys very, very silent. I can't tell if like all you understand or not, if all you quiet. Oh yeah, that's all.
Yes, sir.
Yeah? Okay, cool. Now I need to explain something. Let me just change up this slightly because it don't typically look like this. Right? So Carissa, let's just call this A, call this O, call this B. If I do that, I would write A to B. A to B is equal to what? Tell me fast. A to B is
A
what?
to O. A to O and O to B.
Great. Now, it's important for you all to understand that not all the time they would give you something like A to O. The vector that they would give you would be O to A, not A to O. So, Kadisha, do you
So
understand
at no
that?
point it will never be going the other direction.
Say that again?
At no point it would be going the
Like
other
from B to A
direction.
and A to O.
Yeah.
Say that, as you said, at no point in time would it be going in the other direction.
Yeah.
So you're asking
Like
me
from B to A and A to O.
A to
Like
yeah.
A being the main point. Like to find A O, B O, you'll have to go B to A and A to O. That was like
sometimes it would change, you know. I'm not sure if this is your
Okay.
question, but check this out, right? If I
I
want to
just thought it was standard now. Like
this is the standard case, right? But it could change it to suit your needs. Let's just say you wanted to go from O to A, right? How would I use this triangle to go from O to A? You tell me. Forget about the arrows here. You tell me. How would I go from O to A using this triangle?
you go horizontal first.
Now, it's a bit unconventional in this case. If you
yeah,
wanted to go from O to A, you would go from O to B and then B to A. So, Kadisha,
Oh,
all vectors is just directions. It's just directions. It's literally just directions. So just think about different ways you could go to the same destination, right?
okay.
So this triangular rule of vectors could apply to anything. Once you have 3 points, there's multiple ways you could reach your location, right? But this is the standard one. But what I'm saying is, you won't be given A to O in the exam. You'll be given O to A. So my question to you all is, if O to A, if O to A is, let me just say 5 is 5, what do you all think? What do you all think A to O would be? I'm just curious. Kadisha, think about it. We're using sign to represent direction. So don't you agree that O to A and A to O is the same distance? Yeah?
Yeah.
But
Yeah, just
same
opposite.
direction. Is it the same direction?
No.
No. So would I write +5 or -5?
You will write negative.
-5, right? So I needed to understand that.
-5.
So I needed to understand that A to O is actually the same thing as negative OA. And if it's confusing you, watch. I said that A to O was
So whether it is negative or positive is the same.
You're talking about the size, like the 5?
Yeah.
Well, it depends, eh? Check it out. And logically, O to A, the distance from O to A, wouldn't that be the same as the distance from A to O? It's the same
Yes.
distance. The only thing that changing here is the direction.
Direction, yeah.
So A to O is the exact same thing as negative OA. Because if I put a negative sign in front of OA, that means I'm switching the direction to make it go the
Okay.
opposite direction.
Yeah, yeah. Okay.
Check it out, right? If I have, so you understand that +4 would be here, right?
Mm-hmm.
If I only put a negative there, that would now become this. Understand?
Right.
Let me just explain that one more time. You understand that positive is to the right and negative is to the left.
And negative is to the left, yeah.
So if I only put a negative sign in front of this 4, so if I put -4, this would no longer be correct. It would now be in this direction. Negative.
Right.
So if I put,
Negative 4.
so what I'm saying is if I put a negative sign in front of a vector, I change the direction. Understand?
Yeah.
So if I put a negative sign in front of OA, it means the same thing as A to O.
Okay.
I need a little tell me if that confusing all you.
So
Yeah, Kadisha,
okay.
tell me, run through.
So even though so basically, well, it's just the direction that changing.
Yeah, just the direction changing. Just the direction changing. And you put in a negative to change the direction.
Right. So either way it's equal, it's just the direction changing.
Yeah. So you
Okay.
understand that O to A, +5. Right? So O to A is +5. But A to O would be the same thing, just -5.
Just negative.
So you understand why I'm saying A to O is the same
Yeah.
thing as negative OA. Because OA is in this direction, so A to O could just be the inverse of that, so negative.
Right. Yeah. It's just the direction.
Right. So in other words, you see how I have A to O there? And if I wanted, I could write A to O as negative OA. Or that confuse you, tell me.
So you can repeat the question.
So I could write A to O as negative OA. Some of that confuse you.
Yeah, because it equal is just the direction.
Right. So you understand that O to A would be the opposite, would be going in the opposite direction to A to O.
Yeah.
But if I put a negative in front of OA, wouldn't that flip the direction?
Yeah.
Yeah, so
It's just the direction not changing.
yeah, right? So if I want to write A to O in terms of OA, I just have to put a negative sign there to flip the direction. Right? So I feel like we understand that.
Yeah.
So check this. On the graph, we were able to directly read off what Q to R was. We was able to do that. Yeah? And we was able to read it off?
Yeah.
We were. Right? Sky, I'm gonna call upon you for something. So, Sky, and I could have also used the triangular rule of vectors to figure out Q to R. I'm not sure if you remember that.
So, yeah.
Sky?
So, now you know.
Remember what the triangular rule of vectors is?
So, no.
It was this thing over here. It said that if I wanted to go from A to B, if I want to go from A to B, and I could go from A to O and O to B.
Oh, yeah. Yes.
That's it. That's literally it. Right? Great. So you're on board so far, right?
Yes, sir.
Nice. If the question is asking us to go from Q to R, where am I starting from? Thomas Sky, if I want to go from Q to R, where am I starting from? Q. And I know eventually I want to reach where?
R.
Okay, so check this. And you'll tell me if I'm losing you, right? So the triangular rule of vectors is essentially using a middleman to reach your final destination. So if I want to go from Q to R, so I want to go from Q to R, right? And just see that as Q to R?
Yes.
If I want to go from Q to R, wait, let me just great. So Carissa, you'll tell me if I lose you, right? Kadisha, that's wrong. Only go tell me. So Q to R. Couldn't I also go from Q to O and then O to R? Tell me if you're seeing that.
Yeah.
Yes, sir.
Yeah, and all of us seen it. If you want to go from Q to R, you could also go Q to O and O to R. But pay attention to something. Pay attention to something. We have to go Q to O. That's the opposite direction of what vector? Tell me, Kadisha. So check that again, right?
The opposite.
Is the opposite direction to what vector? So
I don't know.
what's this vector over here? So check it out, right, Kadisha? So this was O, and this was Q. So this vector was going from where to where? That would be vector what? So tell me, Kadisha, you're starting from where and you're going to where? That vector highlighted there.
You start from O and you're going to Q.
Right, so that's vector OQ, right? Understand?
Mm-hmm.
But if I want to take an alternative route to reach R from Q, and I would have to go from Q to O and then O to R.
O to R. Mm-hmm.
But pay attention to something. This is vector OQ.
Mm-hmm.
What would this be?
QO.
Right. Which is the same thing as negative what?
Negative 6. Negative 4.
Nah. It could be negative OQ.
Negative. What? Okay.
Check this out, right, Kadisha? You understand that this, what vector that is again?
Q. OQ.
That's OQ. You understand that?
Mm-hmm.
What is the difference between OQ and QO?
The direction.
Right. So if I put a negative sign in front of OQ, what will happen to the direction?
It would change.
Right. So you can now be going from where to where?
So right now we're going from Q to O.
Right. You understand?
Mm-hmm.
Nice. So in other words, if I wanted to go from Q to R, and I could also go from Q to O and O to R,
And when O to R.
right? Right. We at a juncture where I could like lose a lot of you guys. Even though it's very simple, I could lose a lot of you all. So if you're confused and need it to tell me, right? Right. So Kadisha, let's continue, right?
Mm-hmm.
So earlier we found for vector O to R, we found for O to Q. Seeing that? Let me show you what I'm talking about. So we found for this and we found for this. Seeing that?
Yeah.
So master question. We have Q. This is Q to O. We said that Q to O is the same thing as negative what?
It's the same thing as negative O to R.
Nah. Check it out, right? This is Q to O.
Oh gosh, Q to O is the same thing as negative O to Q.
Perfect.
You get lost easily, boy.
Right?
You get lost very easily if you're not catching up.
I tell you, so I need all you to tell me if you're confused or not, because you will get very lost in vectors if you don't tell me what's going on. And all you know, I don't shame anybody. If you don't understand something, tell me. Right. So Kadisha, we good with everything so far, right?
Yeah.
Nice. Tell me something. And we had found vector OQ previously.
Yeah.
What was vector OQ?
OQ is 5 too.
Right. So wouldn't negative OQ, wouldn't that just be negative outside? 5, 2 here? Tell me if I'm confusing it. I confused it?
No.
All right. And O to R. What is O to R?
O to R would be positive.
Now, check what we found O to R to be. What did we find O to R to be?
Negative.
-1. Check it out over there. What was O to R again?
Okay. Yeah. -1, 4.
Right. Okay. So see how it's negative on the outside? We could apply it to everything on the inside. So -5 is just -5. -2 is just
Mhm.
-2. So you with me so far?
Yeah.
So now we're just going to combine the horizontal components and the vertical components. So you see how and both of us could agree that -5 and -1 are both horizontal movements.
Yeah.
Right. So what's -5 plus -1? Think of it like, okay, so and -5 means you're moving 5 spaces to the, what does it mean?
Left.
Right? So 5 spaces to the left, and then you're adding on a movement to the,
To the left.
right? So how much you move to the left altogether?
6.
Right. So that's going to be -6. What about over here? Let's see. So this would have meant that you move 2 spaces down, and then you're moving 4 spaces up. So what happened there?
2 spaces down and then 4 up.
So imagine, check this out, right? So imagine you're at -2. So you move 2 spaces down. You with me?
Right. Mm-hmm.
Then you're moving 4 up. So from -2, you're gonna go to -1. And from -1, you're gonna go to 0. And from 0, you're gonna go to 1. From 1, you're gonna go to 2. And you can see that we moved 4 spaces up.
Yeah, 4.
So where did we end up at?
Positive 2.
Yep, +2.
I could have said that a long time, but
Right? So yeah, tell me if you're okay with that.
yeah,
And did we get the same answer that we got when we read it off from the diagram?
yeah.
Yeah. Nice. So Carissa, let me know if you're okay with everything so far. Have anything that confusing you? If you're talking, I'm not hearing you by chance. Yeah. Anybody hearing Carissa?
Nah, so
Nah. All right. So I would like you all to copy down the triangular rule of vectors. It's very important that I copy this down. So here, take 5 minutes and copy down as much as you could copy down from here. Take 5 minutes. This is important stuff.
so you'll be sending the notes?
Yeah, I'll be sending notes.
Okay.
I just don't like how everybody's so quiet. If you're confused, you're gonna get even more confused. Like vectors is something that will get you very confused very easily. I had to call names. Anna, tell me if you're okay with everything that's being done.
Yeah, cool.
So you understand that one of the main things I need to make sure you understand. You understand that A to O is the same thing as a negative OA.
Yeah.
Right. And you understand that by me putting the negative here, it just flipping the direction, making it go from A to O instead of O to A.
Yeah.
Nice. Nice. All right. Mark somebody else. Simran, do you understand everything that's on the board?
Yeah.
You're sure?
Yeah.
So tell me this, right? Tell me this. If I have B, O, what's another way I could write B to O? In terms of OB.
What do you mean? Wouldn't it be negative OB?
Great. You're paying attention. Nice. You're fine. Right? Don't worry. I just want to make sure you understand that. Right? Mira, you've been awfully quiet. Not sure what's going on. Right? I feel like it's Christmas, so we're all moving quiet. So tis the night before Christmas.
Very lost.
That's running very low.
Nobody does sleep before Christmas. I just letting you know that one guy.
Yeah, nobody does that before Christmas. Right? Mira, you understand what's going on here?
Yeah, grasping the concept so far.
Okay, do you be real with me? You don't have to sugarcoat anything. Is
Uh-huh.
this confusing you?
No.
You understand that by me putting a negative sign, I just flip in the direction, right?
Yeah.
Great. I need to make sure I understand that. And Mira, what do you think was a smart move? Do you think, okay, so if this question had asked you to find for QR,
Mm-hmm.
do you think you should do this? Or do you think you should just read it off from the graph?
Q to R. I think you should do Q to R.
Right. I mean, both of these is
Yeah, well, it's the same thing, but like
hmm
actually, what do you mean by read it off of the graph, like the coordinates?
Okay, wait. Check this, right?
Uh-huh.
Do you understand that a vector consists of a horizontal movement first, then a vertical movement?
Yeah.
Great. So you could actually read off Q to R from the graph without doing any of this. Did you know that?
Yeah.
Okay. So if I want to go from Q to R, I would have to move 6 spaces to the left and then 2 up. So in other words, Q to R from the graph, which I did in like less than 10 seconds, it'll be minus 6, 2. You rather do that, or you rather do triangular real vectors?
I'd rather do that, to be
Same,
honest.
I rather do that as well, right? This was just a demonstration of triangular law vectors. Yeah,
So I have a question, right?
sure.
To get the max, you'll have to do the triangle.
No, that question like that will be with like if they bring a graph, that will be 2 marks at most. It not worth all of this. They give you the graph for a reason. Like unless they explicitly say use triangular law vectors, then it don't make sense. Just use the graph. Use the graph. Right? All right. So in 17 seconds, I'm going to move on. Okay. All right, so do you all think you're ready for questions? Let me know. Are you ready for questions? Carissa, are you ready for questions?
Yeah.
Yeah.
My brain cells fried already.
Nah, are you joking? I surely am. Like this boy, are you joking with me? Yes, this is too easy. Like I know all you very intelligent. Like all you just joking. This is not hard, right? I go admit when something harder, but all you joking. I can't be telling me this hard.
It's the same.
50-50.
It's 8
Yeah,
50.
50-50.
Great. I hearing Carissa talking, but it's very muffled, like real faint. I think he was talking, but it was sounding real faint, real quiet.
Oh, let's bring the questions. It's 10 to 9.
You ready for the questions, right?
Yeah.
Great.
Chris, I'm ready to
Let's
go.
take it in.
All right, so I want you all to find. I'll tell you what I want to find. All right, so Carissa, enjoy. All right, so I want you all to find the resultant of the vectors w to x and x to y. So all they're asking you guys for when they say resultant is w to y. That's all. So they want you to find w to y. Right, so let me tell you guys what I want you to find. I want you all to find what O to W is, what O to X is, right? I want you to find what W to X is, what X to Y is, and I want you to find what W to Y. Carissa, I asked later. Give it. You ask and you shall receive. I want you all to find all of those. So find for O to W, O to X, W to X, X to Y, W to Y. Right? Let me just make this very clear. Wait, I need to add in one more part. Give me a moment to add in one more part. I kind of left out that part. My bad. Yeah. O to Y. One. Chris, how much time you think you need for this question? And in general, how much time do you all need for this question?
Yeah, it can be 5 minutes.
Say that again?
You can leave the 5 minutes. Might not need so much, but we'll work for the 5 minutes.
Less than 5 minutes.
We'll work for the 5 minutes. Leave the 5
Okay.
minutes.
All right, cool.
Yeah.
And if you want an additional trouble, I want you all
That's
to
all. Let me work this out first. Just now.
wait. It pertains to this question. It pertains to this question. So
Okay.
do 4 to 6. So 4 to 6 using triangular rule of vectors. Yeah, so go. Okay, so somebody asked me where is O. So O is the origin, and I mean 0, 0. So this is O. Yeah, that's O. Could somebody just remind me what you call a vector that starts from the origin? Starts with P.
A position.
Yeah, position vector. Cool. Right, and if it doesn't start from the origin, it's a non-localized vector. All right, guys, how are things going? Is everything okay?
I feel I get you there.
All right, Senate. Correct it one time.
It's correct, but eh,
All right, so there's round. The first one is correct. And don't forget the equal sign, eh? Right, so 1, 2, 5, down. Right? The second one is correct. The third one is correct. Checking out what you have here for the
I did wrong. I did wrong.
yeah. You know, there's round you can read it off. You can read it off from the graph. So, I'm gonna tell you some advice, right? Check this out. If I want to go from W to X, put your pencil by W, move horizontally, and then move vertically until you reach X. And you should be able to get a vector without doing any triangular rule of vectors. I just added in that part. You know, if you wanted to, you could. But you can read that off from the graph. So that's run. Let's do W to X, right? So that's run W to X. This means I'm starting from W and I'm going to X. So if I start from W, how should I move next as run to reach X?
I'm moving right. So you get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Nah, watch. That would be 1, 2, 3. 3 spaces to the right.
Oh, the X. Oh,
W to X.
I checked the Y in it. Oh, sorry.
And what next?
Let it go up.
Up how much spaces?
1, 2. Yeah, 2.
Right. So the vector for W, X would be what?
I got 3, 2.
Yeah, 3, 2. That's correct. All right. So Sky here, man.
Yes, sir.
All right. So I'm telling you 4 to 6 wrong. Eh? Let me show you a logical reason why. So if you want to go from W to X, where are you starting from? Tell me, Sky. If you're going from W to X, where are you starting from? Sky. Say that again.
W.
W, right? And then you wrote YW. But if you say that, that means you're starting from Y, you go into W, then you go into W, and then from W you go into X. But that wouldn't be W to X. You understand what I'm saying?
Yes.
Yeah. All right, so let's answer the questions, right? So Desron, I want you to explain to everybody how you got the first one. Right? So O to W. How did you go from O to W?
O to W.
Yeah.
You're going you're going 1 to the right and you're going 2 up.
Nice. Right, so OW is just 1, 2. Everybody got that correct? 1, 2? Taking it that everybody did get it correct. That's wrong about O to X.
You're going for, I'm going 4 to the right and 4 up.
Right? 4 to the right. Right, so that'll be 4, 4. What about the last one? The last easy one.
You're going 12 to the right and 1 up.
Right. So if you want to go from O to Y, you have to go 12, right? And then 1 up. This is where things go crazy.
Yes, sir, I get all that correct.
Nice. It's just 4 to 6 where things went crazy. Now, first things first, let me show you guys how to get the answer for 4 to 6 strictly using the graph. Right, so Ria and Sky, pay attention, right? So Sky, look at this. This says, it tells you you're going from where to where. What does that mean?
So can you repeat that again? I didn't hear properly the first time.
So Ria, what does this mean? WX, and you see now there's an arrow. What does that mean?
You're going to the right?
Wait, not quite. A vector is just directions, right? So for instance, if I want to go from O to W, I would have to move 1. So, Ria, pay attention, right? So if I want to go from O to W, it means I'm starting from where? Where does it mean I'm starting from?
The horizontal?
No. O to W. Where am I starting from?
Oh.
O. So
Right.
from O, I'm going to move 1 space to the right, and then I'm going to move 2 up. That's what vectors is. That's the concept of vectors. So over here, when you see WX and the arrow is like this, that tells you you're going from where to where.
From W to X.
So where should you be starting from?
From W.
Exactly. So you're starting from W. So if you start from W, how would you, remember you're moving horizontally first, right? Tell me, how would you move horizontally and then vertically to reach X? From W.
You go like 3 spaces to the right.
Right? Yes. What next?
And then 2 spaces up.
Yep. That's the answer.
Oh. That's too easy.
I tell you, vectors is very, very easy. I don't think I'm lying. Vectors is so easy, right? So that'll be 3, 2. So W to X is just simply 3.
Wait, how is 3 2? You count the spaces for that one?
Yes, check it out.
Okay.
So starting from W, I have to move 1, 2, 3 blocks, and then again starting from W is here. I have to move 2 blocks.
Okay. So when you're not starting from the origin, you count the spaces instead of the actual numbers on the graph.
Yes, because Ria, and if you're starting from W, take it easy.
No, it's not.
If you're starting from W, right? This is directions. So if you want to reach W, if you're starting from W and you want to reach X, the directions would be like this. Okay, move 3 spaces to the right, then 2 up, and get through, right? Vectors is just directions. So if you're starting from W, and you would have to move 3 spaces to reach from 1 to 4.
Yeah.
So I think you understand it, right?
Yeah.
Right. So 3.
I just wanted to make sure now, like, that we count in spaces and not numbers. Yeah.
So Ria, this whole time, I'm not shaming you, but a lot of students do actually understand the concept. What do you think this was? Because now you understand this. This simply it just simply means
No.
O to W. But wait, what you
Yeah,
before?
I did understand from 1 to 3, but it's 4 to 6 is where like I had the rule in my book and I was trying to understand it and I didn't. So I was just like, you know what, I'll just wait for Sue to do it and I'll ask him to help me.
Well, this was a graphical solution, right? If I wanted to solve it using the triangular rule of vectors, I'm gonna show you how you would do that. But you understand the graphical answer, right?
Yes.
Sky, do you understand the graphical answer? Sky? Yeah or no? Can I hear him? Sky, I see you on mute. Do you understand the graphical answer?
Yes, sir.
Right. So you understand you're starting from W. So from W, you have to move 3 spaces to the right and then 2 up to reach X. The 3, 2. Right. So before I use the triangular rule of vectors, let's just figure out the other answers while we're at it. So Ria, just to make sure you understand it, if it's X, Y, where am I starting from?
From X.
And I want to go to?
Y.
Right.
From X to Y, yeah.
Right. So I'm starting at X, horizontal movement first. How do I move? To the left or to the right?
To the
You're going through it, but you're going through it.
it's not me.
Oh, that's
Anyway,
not you. Oh, that's your mom.
yeah,
Hey.
from to the left.
To
To the right. Sorry, the right.
Left, right, left, right.
You're right, you're right.
And you know that song? All right. So obviously we had to go to the left. What's I saying?
The
You
left?
get to me, you get to me, you get to me. Gotta go to the right, right? Because Y is over here and X is over here. Y is to the right of X. Right? So how much spaces do you have to move? Let's count. 1, 2, 3, 4, 5, 6, 7, 8.
Ah, okay.
8. Let me check that back one more time because I have trust issues. Right? Not the only one that has trust issues. I'm sure that you all have trust issues. Color should use boy. These are orange. Right. 1. Okay, 1, 2, 3, 4, 5, 6, 7, 8. 8 is the correct answer. Nice. I'm not blind.
And then 3 spaces down.
Gosh, man. All right, yeah. So 8 and then
3 spaces down.
right. What the vector for that will be?
8. 8 over 3.
8 minus 3.
Well,
remember, if you're going down,
right.
Negative.
Right.
Right? 8. Right? And Sky, I want you to help me with the last one before we do triangular rule of vectors. Actually, Desron, you understand how I got 3, 2, and 8 minus 3?
Yeah.
From the graph itself, right?
Yeah.
Nice. Sky, question 6, you there?
Yes, sir.
So Sky, what does this mean? Like in English, what does that mean?
Yes, you're going from W to Y.
So where am I starting from then? Where am I starting from?
No, my given problems. I say W.
And where you going to?
I.
Right. You're taking a what movement first?
A horizontal.
And then a
Vertical.
right. So gonna start off at W. Should I move to the left or to the right?
Right.
Right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You okay with that?
Yes, sir.
And what next?
Yeah, moving one space.
Right, one space down. So that's going to be 11, 1.
11.
But when I'm writing the vector though, am I going to put +1 or -1?
Negative 1 is downward is negative.
Nice. So, Carissa, were you able to get the answers?
Yeah. I guess,
Nice.
yeah.
You use the graphical method or you do the
The graphical.
calculations?
That next part is confusing.
The
The triangle.
okay, don't worry. You see what I say? Like vectors easy, you know, but very easy to get lost. So don't worry, I will show you how to do triangular ruler vectors. Don't worry. Right? So let's see. Is buddy. So this is 11, 1. Right, so I'm sure everybody understands the graphical method, but like that triangular ruler vector is just frying on their brain. I get it. It's understandable, don't worry. All right. So Carissa, are you ready to do the triangular ruler vectors now?
Yeah. Let's
Okay,
try.
great. So you understand that we're starting at W and you're going to X.
Yeah.
So the first vector has to have W in it, right?
Mm-hmm.
And it has to end off with X. So we need a middle point here.
All right.
So we have OW, OX, and OY.
Mm-hmm.
So can't I say W to O and O to X?
Yeah.
Yes. And how would that look like on the graph?
Didn't look right.
Say that again?
I say I started off with that, but it didn't look right.
Check it out, right? If I connect W to O and I
Mhm.
connect O to X, it's gonna make perfect sense. Check it out. We want to go from W to X, right? So to go from W to X, I would have to go from W to O and O to X. Seen it?
Yeah.
Nice. Well, let me ask that question. Do we have W to O?
Yeah. We have O to W.
Right. So W to O is the same thing as what?
O to W.
Nah. No, not quite. This you have to put negative
Okay, negative O to W.
because W to O is the same thing as OW, just the sign had to change. Right?
Right.
Flip the direction. We have O to X, so we don't have to worry about that. Great. So I'm going to put what's OW? Remind me.
1, 2.
2. And O to X was?
4, 4.
So you're gonna end up with -1, -2, and you're adding that to 4, 4. So imagine you move one space to the left and then 4 to the right. What would that simplify to?
1 to the right.
Right? 3 to the right.
Mm-hmm.
And imagine you move 2 spaces down and then you move back 4 spaces up. What would you end up at?
And 4 spaces are up.
Yeah, so -2 means you move 2 down and then you're moving 4 up. So imagine -2 here,
Mm-hmm.
up 1, reach -1, move up another 1, reach, wait, right there. Right. So you move down, So at -2, move 1,
Mhm.
reach -1, move 1 again, reach 0, move 1 again, you reach 1, move 1 again, you reach 2. So if you went 2 units down and then you move 4 up, you reach 2. You could just say -2 plus 4. But I just showing you how it look like graphically, right?
Yeah.
So you understand that?
Mhm.
Did we get that from the graph?
Yeah.
Yeah, so it's correct. Right, so I'm gonna call upon somebody else. Chris, I want to volunteer somebody.
Me?
Yeah.
Missy Jackson.
They can't hate you because you're helping them out. They're probably too shy, so you had to get them a push or something.
Yeah. Yeah.
Hmm.
Ali.
Actually,
Who's Ali?
Jada.
Jira Ali.
Jada.
Jira, you there? Boy, Jira. Jira, use my real friend and you just leave me hanging, so boy. Wait, boy. Hmm, that's crazy. Anna, you wanna help me with 5? Why everybody so quiet for? Simran, you there?
Yeah.
Okay, Simran. Let we tackle question 5, right? So the vector is xy. That means you're starting from where?
X,
And you're going to where?
Y.
So if we want to use the triangular rule of vectors, I need a vector starting from x, right? And then I need to end up at y. So we're trying to figure out what the middleman is. If you look at the vectors we found earlier, O to W, O to X, O to Y. Could you figure out what the middleman would be? So X to where, then where to Y?
X to O.
Yes. Perfect. X to O and O to Y. Right? Write this bigger. Right, so X to O. And let's see how that would look like on the graph. So tell me if this confusing you, right? So that's what O to X would look like. Wait. This is what O to X would look like. That confused you, I understand that. That's O to X.
I understand.
And O to Y. What would O to Y look like? That would be like that. So just by looking at the graph now, I think you could see it. If you want to go from X to Y, and you would have to go from X to O and O to Y.
Yeah.
But check this. If this is O to X, you'd be going in the opposite direction. So this goes into what? What OX?
Negative OX.
Perfect. So instead of writing XO, I'm going to write negative OX. Right? What was OX?
Four.
Right? And what was OY?
12, 1.
Right? So you're going to end up with -4, -4. Right? So -4 plus 12 is? Simon? -4 plus 12. You guys can use a calculator, I know. Yeah. Use a calculator if you're having trouble. Can I hear and Simran? Could somebody tell me what negative 4 plus 12 would be?
8.
It's negative 3.
Right? 8, negative 3. Yep. I believe. Thank you for helping me for most of it, Simran. Right. Desron, you want to help me with the last one?
Yeah, no sin.
Okay. Okay, great. So I think you all realize that you could always pivot around the origin. The origin could always be middleman. Once you find the position vectors, you could do nearly anything you want. All right? All right, so let's run. W to Y. That means we're starting from where? Where are we starting from?
Yeah, starting from W.
Right. This literally means W to Y. Right? So
Yeah.
if I want to go from W to Y and I want to break up a movement into parts, I would need a vector that has W in it, and I would need the other vector to end off with what let's run. So some vector here plus some vector here, but wait, how to end off?
Y.
How to end off with Y? How to end off with Y? Right. Now, it have any vectors we found for earlier that looking similar to W, like this format now. We think I should pause the middleman.
We go from W to X.
No,
W to O, sorry.
You could if you want to know. I'll show you something else now, right? W to O and O to Y, right?
Yeah.
Great. W to O is the same thing as what?
A negative O to W.
Yes. What is OW?
A negative 1 negative 1.
Oh, you do know one time. Let me break it up into parts. So OW itself, and that was 1, 2, OW.
Yeah.
Right?
Yeah, 1, 2.
And what was OY?
OY is 12, 1.
OY is 12, 1. Great. That negative outside gonna make everything on the inside change its sign. So negative 1, negative 2 plus 12, 1. What's negative 1 plus 12 does, Ron?
We got 11.
Right. And negative 2 plus 1?
A negative 1.
Right. Can we confirm that we got that from the graph itself?
Yeah.
Yeah. And if you wanted to see it graphically, check this out. So if I want to go from W to Y, I would go from W to O. Let's check it out. W to O. That would be over here. And then I would go O to Y. Right.
Wait, true, don't we?
All right, Ezra, tell me if you understand that.
Yeah, for sure.
So you can see it for yourself, right? If you want to go from W to Y, and you could just go from W to O and then O to Y.
Yeah.
Yeah. But that's not the only way you can answer this question, girls and guys. It's not the only way you can answer it. Let me show you another way to do it. So that's wrong. Earlier it was telling me something about X, right?
Yeah.
If I check this right, we know the vector needs to start off with W, need to start off at W, right? And it needs to end off at Y. So really and truly, you could use anything as a middleman once you have the vectors, right? So if you wanted, you could use wx and xy. But my question is this, Ron, do we have wx?
Yeah.
Okay, we have wx. What was wx?
That's all right.
Let me see.
Yeah, because 3-2.
3-2, right? And what was xy?
Actually, 8 minus 3.
Right. So that'll give you the same answer. So really and truly is up to you guys, eh? Like whichever one you see, you could use. That's the cool thing about vectors. I can tell you directions and it have more than one path you could take to reach the end location. So let me show you. Let me show you guys what Desron just said. So Desron, if we want to go from W to Y, I'm just putting that on the graph. W to Y. And this will be W to Y.
Yeah.
Yeah, this will be W to Y. W to Y. Check it out. If I want to go from W to Y, and I could just go from W to X, X to Y. Did you see it? Yeah. Carissa, I don't know if you're seeing that. So if I want to go from W to Y, and I could also go from W to X and X to Y.
Yeah.
Yeah. So there's multiple paths you could take to reach an end destination. So there isn't just one correct answer. There's multiple correct answers. Because Carissa, and you understand, like check this example I gave earlier. And it have multiple ways you could reach from Pinal to Port of Spain.
Yeah.
Yeah. The point is, once you're starting from Pinal and you end up Port of Spain, it's correct. No matter where you do in the middle.
Okay.
Right? Right. So how you feeling about vectors? You feel like you understand a little better?
Yeah.
Okay, that's good.
Makes sense.
Right. Oh,
I was for the homework.
you're real enthusiastic about this boy. I
Yeah, because I feel like homework now going to be
You feel the homework gonna be hard?
yeah, it's not hard. Until I take your time and I went through.
I'm telling you, none of this hard, eh? It's only looking hard. It
Yeah,
only
you
looking hard. When you
made for that.
The real practice with them past people.
when only practice and thing, all gonna be fine. Trust me.
Mhm.
Also, let's see that this stuff very like a lot of people they say math is not common sense, but Carissa, and when if you sit down and you look at this, and you can see it's just directions.
Yeah.
Yeah. So I would say it's not bad.
You must say it's not hard.
No, I used to really struggle with maths.
You teach in the class, you must say it's not hard.
No, I used to really struggle with maths. I could tell you if something would be easy or hard. I could tell you. Trust man, no one man's hard. This is not that hard. You
That's
could
all
figure
it.
it out. You must show you it's hard.
No, I don't want to say hard.
Okay.
Yeah, so don't confuse me right now.
I
Okay.
know.
So we at a okay juncture, right? I'm leaving you all
Yes.
at a good ending. We
It have
understand.
vectors.
I say that again?
It have motor vectors.
Yes. Let me tell you exactly what it have other than this in vectors. You need to know how to find the magnitude of a vector. That's just the square root of x squared plus y squared. You need to know the angle between a vector and the x-axis. That's just tan inverse y over x. You need to know what collinear vectors are. What else?
Saying vectors easy.
And you need to know what unit vectors are. That's it. That is the vectors.
Okay.
This is just a formula you need to memorize. But surely how to come up with it though, obviously. That's essentially Pythagoras theorem there. And this is trig ratios. Again, you'll be fine if you just remember these and apply it. It's not like you have to figure it out in the exam, right? Collinear, we secretly looked at collinear vectors today, and a unit vector is another formula, right? If you want to find a unit vector, it's just the vector divided by the magnitude of the vector. And that vector will have a magnitude of 1. So that's it for vectors. Then we finish. So if all goes well, we could finish vectors in the next class, and the class after we just pass papers.
Okay.
Yeah. Let me get the homework. Carissa, I feel like you're a lucky person. You want to give me a pass paper? Yeah. Come on, yeah.
2009.
2009?
Yeah.
Yay. 2009 is crazy. Do I even have that? Let me see.
What's 20?
Yeah, I have it in my notes. That's FIFA 1. For sure. No, but I have to go up to 2011. No, I have 2010 here. Check 2010.
No, we take 2010. Oh.
Okay. It's only looking hard. But it's manageable. I could run through it now. It's not it's now 9:34. Because I got 6 minutes. I could take 6 minutes and explain it to you. So when you're doing it for homework, you wouldn't be lost. Right? So Carissa, the takeaway from today was just vectors, it's just directions. That's all. The diagram below, not drawn to scale, shows triangle JKL. M and N are points on JK and JL respectively. We're not seeing it, but they're there. Such that JM is equal to a third of JK. Does that confuse you?
Yeah.
Okay, check it out, right? So they are saying that JM is just a third of JK. So we can see that this is JK, right? And they're saying that JM is just a third of JK. So this is where M is. And let me explain why. If I cut this into three portions, and they're telling us that JM is just 1 out of the thirds of JK.
Yeah.
So the just so that you understand the first part. Yeah. Then they're saying that JN is a third of JL. So if I cut this thing into 3 pieces, then L would be over here.
Right.
Nice. Copy the diagram in your answer booklet and show the points M and N. I just showed you that.
Yeah.
Given that JM, so M gonna be over here, N gonna be over here. JM would be U, JN would be V. So write in terms of U and V an expression for J to K. Again, that's not so hard, right? J to K, they're telling us that JM is a third of JK. So in other words, Carissa, wouldn't it take 3 JKs to make 1 JM?
Yeah, because it's a third.
Yep. So they already tell you that, okay, so they tell you that JM is just a third of JK. So we found out there. And N would be over there. I'm telling you that JM is U and JN is V. So if you know that JM is equal to U, right? Wouldn't JK just be 3U?
It would.
Yeah.
So you could write it like that. No bracket.
Just be 3U. And if you want to go from M to N, you'd connect M to N. And to go from M to N, you could say M to J and then J to N. Seeing that?
Yeah.
Right? And that wouldn't be hard. because J to M is U. So M to J would be minus U. J to N is V. That wouldn't be hard.
No, that confusing. It's okay.
Confusing. Check it out, right?
Pretty much.
So this
I
is
must with the U.
right. We call him J to M U, and we call him
Right.
J to N V.
Right.
If I connect M and N together,
Right.
if I want to
It'd
go from M to N, and so I could go from M to G and G to N,
Right. Yeah.
right. But let me ask you a question. They're telling us that G to M is U. But what if you go in the opposite direction? It'll be positive U or negative U.
Negative U.
Right. See, understand? Because I'm changing direction, I need to put the negative to show.
Right.
Right. So if I want to go from M to N is just simply that'll be M to G plus G to N. M to G would be minus U, and J to N would be plus V. That's it.
Yeah. Okay.
Right? So it only looking hard, but it's very manageable. And then K to L. K to L. Right? This one might be a bit harder, but I promise it's still very manageable. If you want to go from K to L, and you can go from M to K. Wait there. You're gonna go from K to L. You could go from K to M, M to N, and N to L. Check it out. Check that out again, right? If I want to go from K to L, and I could go from K to M to N, and N to L.
L. That'll be minus N to L. Minus V. No. Would it be considered V still?
Always still be considered V.
No, the N to L wouldn't be V, it would just be N to L.
Wait. Say that back one more time. You're talking about the M to N?
Yeah, how you're going, it wouldn't be considered the U and the V no more.
It would. So long story short, this would be 2U. This would be 2V. Because remember, wouldn't I need 3 of these guys
to
make up the entire thing?
Yeah.
So the entire thing would be 3U. If that's the case, then this would be 2U. So K to M is 2U. Right? And N to L would be what? See if you can figure that out.
N to L would be 2V.
2V. So we could figure that out so easy. Check it out, right? K to M is what? 2U.
Right.
M to N, we found out as minus U plus V. And then N to L, that's going to be plus 2V. From there, you just simplify. That would be 2U minus U is U. V plus 2V is 3V. I don't know where it went, but I think you get the idea.
I tell you, the homework wouldn't come easy.
So you think you'll be able to handle it for yourself? Like,
I told you the homework will not come easy.
okay, but let's be realistic, right? If you sit down and you're patient and you try to understand the logic behind it, is it insanely difficult?
No, it wouldn't be insanely difficult.
It's not. I can show you some vector questions that kind of hard, but this one, I understand it tough, but it's not impossible. So this one, I'll send this one to you guys. Give me one more year. Not you, somebody else. I want to see if they could pick a harder question. Ria, give me a year.
2011.
Okay. Bet. Okay. This one looking nice. But this one will be
So we could do our next one. What is this?
Okay.
And these things don't have graphs on them.
Here what, right? if all I have time, I could do one of the difficult questions with you all. All I have time? I don't mind, I love maths. I've done maths for 24 hours straight. It's small.
Yeah, so we could tell.
Or I could if all I want not to go through this, I could go through it now. It's not a problem. After all, yeah. Is essentially what we do today. It's nothing hard.
We outside.
I like that. So here, well, I'll just run through this question quickly, right? So Ria,
Yes, you could do it.
so they're telling us that XYV is a parallelogram. V to Y is A, all right? V to Y is A. Seeing that? They're calling V to W B. So you okay with everything so far?
Yeah.
S is a point. This is where things get complicated. S is a point on WY. So you're seeing that this is WY and S is a point here, such that WS to SY is 1 to 2. That probably real confuse you. Yeah.
No.
No? Okay, so let me explain what that means, right? Let me explain what that means. So they're saying WS to SY is a 1 to 2 ratio.
So I could try to like say what I think it is before I tell me.
Sure. Come true.
So it say is 1 to 2 because the space between W to S is like 1, and then from S to Y is 2.
That's a perfect way to explain it. Perfect.
Okay.
Because
Okay.
what? You could see that, watch. In other words, it would take 2 WS's to make up S to Y. That's essentially what they're saying. So S to Y is equal to 2 WS. Yeah.
Okay.
That's it. That's what they're saying. And you can see it for yourself, right? Watch. Some of you see it.
Yeah.
Nice.
I could have see it like immediately after the ratio part.
Nice. Right? Write in terms of A and B an expression for W to Y. Let's handle that first. So if I want to go from W to Y, how would I do that?
From W to Y. So this way we are go horizontal first.
Okay, so wait, typically you would, but these kind of questions, they're not standard like that. But so I want you to kind of piece it out from your head. I just want you to think strictly in terms of direction. Just strictly direction. Before we do anything, I just want to point out something. This is a parallelogram, which means that the parallel sides they have the same length and same direction. So Ria, if this is B, this will also be B. If this is A, what do you think this would be?
A.
Great. So tell me, how would I go from W to Y? Again, just think about it strictly in terms of direction. So I want to go from W to Y. If I want to go from W to Y, that means I'm starting from what point?
From W.
And I need to go to
Y.
Right. So I'm starting from here.
So from W to X.
Yeah, you can do that. W to X.
And X to Y.
Yes, that's correct. Right? So W to X. What's X to Y, you said?
Yeah.
Great. What is W to X?
A.
Right, W to X is A. And notice you're going in direction, right? So it's A.
Yeah.
X to Y, though. You have to be careful about that one.
It's B.
No, not B.
No. Oh.
Watch. Y to X is B. You're going from X
The
to
position.
Oh.
The direction.
Okay.
It'll be negative.
Yes.
Negative B. Right,
Yes.
right.
So in other words, I could write xy as negative yx, right? Because yx is b, but this is in the opposite direction, so it'll be negative b, right? So my answer would just be a minus b. We okay with that?
Yeah.
Great. I'm telling all that. This only looking harder. Right, let's do the other one, W to S now. Here one, we just now found for a piece of information and we put it in one time. So W to Y is A minus B. Great. Let's move on. All right, before I do that, let's put minus B over here. All right, so W to S. Where am I starting from? Where am I going? Where am I ending up? Wait, where am I starting from and where am I ending up at?
You're starting on W and then ending on S.
Right. So here to here, right?
Yeah.
Okay. How would we do that?
Would you go W X and X to S or W to V?
So
I was thinking one of those, yeah.
W to V and then V to S.
Yeah.
Or you could say W to V, V to Y, and Y to S. But here what, guys, is an extremely easy way to figure that out. I don't want to gloss over this, right? Carissa and Ria, remember at the start, we read the ratio, and we could see that, well, W to Y could be divided into 3 sections.
Yeah.
And Ria, didn't you tell me that W to S would be one of those sections, and S to Y would be 2 out of those 3 sections?
Yeah.
Great. So in other words, W to S is actually just what? Is what fraction of W to Y?
1/3.
Yes. And while you're at it, SY will be what fraction of WY?
2/3.
Excellent. You ready for this? You ready for CXC, boy? Carissa, let me know if you understand that.
Yeah.
So for anybody that's confused, look at the ratio. W to S is 1 part here, and SY is 2 parts. Altogether, they make 3 parts. I think you can see it like this, watch. 1, 2, 3. Out of those 3 parts, WS would be 1/3 out of the whole vector WY, and S to Y would be 2/3 out of the entire vector W to Y. Great. So we know that. So WS would just be 1/3 of W to Y. And what did we just find? Tell me, Carissa, what we just now find for?
That's the answer?
No.
Oh.
Tell me, Carissa, what did we just now find for in part A?
W to Y.
Right. So now I could make a substitution. W to Y is just A minus B. So I'm going to end up with 1/3 A minus 1/3 B. That's it. Easy?
Simple enough.
Nice. Ria, you understand?
Yeah.
Nice. Let me
I
just
feel
write this.
me off is the letters.
Letters, I understand.
I thought it was W to V.
Okay, no, I hear what you're saying, right? Carissa, I hear what you're saying. You're saying like W to V and then V to S could work. Understand? I will say. But my question is, how would you find for V to S? That's the problem.
So I just think you have to make a triangle when you're doing it, right?
No, that's valid. That's typically what has happened, right? But truth be told, you could break it down into any amount of segments you want to reach a final destination. It don't have to be a triangle.
Okay.
Doesn't have to. If you did wanted to use our route, this question would be very, very hard. Very hard. But Carissa, you understand at the start where they tell you here. They tell you WS is 1 and SY is 2.
Yeah.
So in other words, I could cut this up into 3 parts. How much parts out of the entire thing WS is?
3 parts.
No, 1 out of the 3 parts.
Oh, okay.
And SY would be how much out of the 3 parts?
2 out of the 3
Right.
parts.
So in other words, WS is actually just a third of the entire vector WY. So that's how I got this.
Yeah.
And well, SY would just be the other portion, which is just 2/3 WY. Great. And if you notice, they made us find for WY the first part. So they want us to substitute what we found for WY because they want the answer in terms of A and B.
Mm-hmm.
See, okay?
Yeah.
Right? SX. How would I go from S to X?
S to Y and Y to X.
S to Y and Y to X. Great. Great. That's correct. Right? S to Y. S to Y would be what?
2/3.
Right? Right? And Y to X is?
B.
Perfect. You can't leave it in terms of WY, so you need to convert that to what WY is. That's A minus B. So A minus B plus B, you're going to end up with 2/3 A minus 2/3 B plus B, and you're going to end up with 2/3 A minus a third B. Why did I say a third B? Well, 1B is the same thing as 3 over 3B, right? So from there, I just said minus 2 plus 3, which is 1. So I get, and if that's the case, supposed to get positive 1. Yeah, my bad. Positive 1 over 3B. So, Chris, I understand what I'm saying, right? So, 1B, and you would agree that 1B is the same thing as 3 over 3B? I can write it like that if I want.
1B.
1B is the same thing as 3 over 3.
Right, yeah.
So, since the denominators are the same now, I could just say minus 2 plus 3 was minus 2 plus 3.
Right.
Now, minus 2 plus 3 is 1.
Yeah.
If you have 3 and you take away 2, that's 1. Right?
Tell me about the plus and the minus and the minus and the minus.
That is tie up.
I just need a reminder.
No,
I'm
like,
not a plus and a minus.
that minus sign on thing is real tie up, people. I myself, like, I you know how long it take me to understand that? So I don't blame all you. Yeah. So 2/3 A plus a third B. That's the answer there. You understand it?
I think I get lost from somewhere in the middle there.
With the algebra.
Mm-hmm. You start to put plenty things on the screen.
All right, so you're okay up to this point.
Yeah.
All right. And then they want the answer in terms of A and B. So we know that WY is A minus B. So instead of writing WY, I wrote A minus B in place of WY.
Okay.
Then I multiplied.
Let me start over from the SY plus the YX.
You're gonna start over from there?
Start over from there.
Okay. So if you want to go from S to X,
Right.
you could go from S to Y.
And Y to X.
Right. Now, S to Y is actually just 2/3 of WY.
Okay.
Check it out again. This whole thing is WY. This would just be 2 out of the 3.
right? And plus the B, right?
Mm-hmm.
The B, Y, and the X, right?
Right? And then I replace WY for A minus B, and then I expanded the brackets.
Oh,
So 2/3 by A is 2/3 A. 2/3 by minus B is minus 2/3 B, right? Plus the B. So tell me if you're with more up to this point.
that's fine. The plus the B, right? You replace the Y and the X, you get the A minus, right? And then the equation here itself, 2/3 are A and 2/3 are B. Okay,
So all I did was I expanded the bracket. So 2/3
right,
by A is 2/3 A, and then
right,
2/3 by minus B, a positive by a negative is a negative. So I get negative 2/3 B. That's this.
right,
And then I put back the plus B that was on the outside. That was all
right.
it.
Okay.
Yeah. You okay with that?
Yeah.
All right. And next thing, notice we have a B term here and a B term here. So this is minus 2/3 plus 1. Minus 2/3 plus 1 is a third. So that'll be a third B.
Right.
Yeah, so that's what I got my final answer. I feel like this part confused you. Like, how did I go from this to this? Yeah or no?
Actually, the plus and the minus and the minus and the plus and the I need a refresher on that.
Okay, so
A plus and a minus is equal to what?
wait. If it's multiplication, then a positive by a positive is a positive.
Right.
A negative by a negative is a positive. Right? And everything else is a negative. So positive by negative is negative. Negative by positive is negative. If it's addition, it's a bit more complicated, right? But you understood how I got this part over here when I expanded the brackets, yeah?
Yeah.
Right. It's just this part confusing, yeah.
I get no.
So watch. I have negative 2/3 B, and I have plus 1B. Now 1B, I could write that as 3 over 3B, because 3 over 3 is the same thing as 1.
All right.
Since the denominators are the same, I could go ahead and add the numerators. So that'll be minus 2 plus 3 all over 3B.
Mm-hmm.
Minus 2 plus 3. Okay, imagine you're owing somebody $2 and you pay them $3. And you have a credit at 1?
Yeah.
Yeah, so that'll be positive 1. Right? Another way to think about it is, imagine you have $3 and you take away 2. How much money you have remaining?
Yeah, it'll be 1.
Right. So that'll be, you're going to put 1 over 3B. That's how I get 1 over 3B.
Okay.
Yeah. So that's it there. Last one. R is the midpoint of VW. Okay, VW. So I'm just put that in. R is the midpoint of VW. Prove that R, S, and X are collinear. So, Ria, I'm not sure if you're still here, but do you know what collinear means?
Nope.
Okay. Collinear. That means a line on the same line. Check it out. Does it look like they're on the same line?
No.
You sure about that? Watch. R, S, and X. You sure? I find it looking like they're on the same line, you know?
Oh, R, S, and X. I thought you was going from B to X, my R.
And
yeah, it could work.
now it will work because watch. I think all of us seeing that it's collinear, but we need to prove that it's collinear. Now, what does something mean to be collinear? For something to be collinear, check this, right? so Ria, r to x, and as a big vector,
Sorry?
check it out. And we have a big vector over here, r to x.
Yeah.
All right. If r, s, and x are collinear, it means that r to s would just be some fraction of r to x.
Right.
Let me explain what I mean. Let me explain that one more time. So r to s is the big vector. Now, if r and s are on the same line, then it should just be, the only difference should be the size. So like, in other words, I should be able to write r to s as some fraction of the entire thing. So you see how we was able to write these as fractions in terms of fractions?
Yeah.
If they are collinear, we should be able to do that. So Ria, so you see, nth w to y is one big vector.
Yeah.
nw to s is a smaller vector.
Mm-hmm.
But are they on the same line?
Yeah.
Yeah. nw to s and w to y on the same line?
Yeah.
Same direction, right? So if it's the same direction, I should be able to write them like this. So I should be able to write ws as a third wy because on the same line, one just smaller, right? So if these points are collinear, then I should be able to write rs as some fraction of rx. That's what I should be able to write. Should be. So let me show you how we can do that. All right, rs. We need to find rs first. How would I find rs? Tell Maria. I want to go from r to s. How about doing that? I'll help you out a little bit. And we could go from r to w and w to s.
Yeah, I'm going in the opposite direction, but yeah, that would too.
That'll be simpler because if you're going in the opposite direction, check that.
Yeah. R to W.
So you agree with me, like that's what's gonna happen.
Yeah.
All right. R to W wouldn't that just be a half of B?
Yeah.
Because if B is B to W and R is the midpoint, then from R to W would just be half of B, right? And we know what W to S is. W to S, we found out earlier. That was a third A minus a third B. Yeah? Tell me if you're okay with that.
Yeah.
All right. So we have, R to S, that would just be equal to, and we said R to W plus what?
W to S.
Right, so that's going to be a half B plus a third A minus a third B. So we have to group together the like terms. We have a half B minus a third B. What's a half minus a third? Should be 1/6, I think. I'm not sure. Check it. A half minus a third. Is it 1/6? Yeah, it's 1/6. Nice. Plug it into the calculator. So you're gonna put 1/6b plus a third a. Right? So a half minus a third is 1/6. So that's what R to S is. Do you think you'll be able to figure out what the big vector is? So the big vector would be from where? So we just
from S to X.
Right. S to X. Now, even bigger than that.
Oh, um, R to X, right? Right.
Right? R to X. R to X. If you want to go from R to X, and we could say R to W, right?
And W to X.
Mm-hmm.
No.
R to W and W to X. Mm-hmm. So R to W, that's going to be a half B plus A, right? So proof time now. So like, check this, right? RS is 1 over 6B plus a third A. If I were to factor out the third, then that would be 1 over 2B plus A. And we know that this is actually Rx. So in other words, R to S is just a third of Rx. So tell Maria, were we able to write Rs as a fraction of Rx similarly to this?
Yeah.
Once you can do that, a collinear. That's how you do it. I understand I'm probably type real people here. This one kind of tough. I will not lie. This one requires mathematical intuition. This one tough. So Ria, we got Rs to be this and Rx to be this. I think you could figure out up to this part. Yeah?
Yeah.
Right. Because it was simple, right? I mean, you know what to do. Yeah. You know what to do. This part is
Yeah.
the hard part. Rs and R. Wait there. Have two ways you could do this, right? Two ways you could do this. But sure, yeah, this way. Tell me something, right, Ria? Isn't Rs just a third of Rx?
Yeah.
Check it out, right? If I cut it into 3 portions, this is 1, 2, 3. Rs is actually a third of Rx. You can see that visually, but we need to prove that. So if I were to factor out a third from this, I'll be left with 1 over 2b. Why? Because a third by a half is 1 over 6. And if I factor out a third from 1 over 3a, it's just plus a. Doesn't this look familiar? A half b plus a. A half b plus a. Where you see a half b plus a?
RW plus RX, WX.
Go one step further. Like one step before. What vector is that?
RX.
Or Rx. So I could write, so in other words, I could write that Rs is a third of Rx. So once you could write that a vector is just a scalar multiple of another vector, you're good. I say in big words. Scalar multiple just means you're multiplying it by a number. Once you can do that, it's cool, right? I wouldn't lie, this is the only part that I think was really tough. It's the only part. When we do practice, you'll get it. Right? So Carissa, minus part 2. You think like you could manage up to this part?
Yeah. That last part I was leaving out for sure.
So you see, I'm honest. I could tell you when something will be hard, right?
It was hard still. It was taxing the brain, but
Yeah, but when we do practice, it will be better, right? Trust me, it'll be better. So yeah, guys, that's it for class today. I'll give all you one question for homework, or I could stress all your brain on that. Right, just one question. Yeah. So thanks for coming to class today, guys. I will see you all. I'll see some more there tomorrow. Right, some more there next week. So later, guys. Have a good night. Bye.
Bye.
Bye, Joshua.
Good night.
Good night.
Bye.